Hello and welcome to the next video in my pre-algebra review series. Today's video reviews Chapter 4, Section 4, entitled Simplifying Fractions. By the end of this video, you should have a better understanding of equivalent fractions and writing fractions in simplest form. Be sure to leave a like if you have found this video to be helpful. Be sure to leave a comment if you would like me to cover any particular topic a little more in depth. Thank you. Before we start looking at fractions, I have a few definitions that we should probably go over. Equivalent fractions. And equivalent fractions describe the same part of a whole. In simplest form, a fraction is in simplest form when the numerator and denominator have no common factors other than 1. You can use the greatest common factor to write a fraction in simplest form. So what are equivalent fractions? So each fraction model below represents one whole item. The blue model is divided into 4 equal parts. The orange model is divided into 12 equal parts. Take a look at them. You can see the 12 parts and the 4 parts. The fraction models show that 3/4 is equal to 9/12. You can count them 1, 2, 3 out of 4 on the top, and 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12 on the bottom, in the orange model. So the fractions 3/4 or 3/4 and 9/12 are equivalent fractions because they describe the same part of a whole piece, the same quantity relative to the whole. You can find equivalent fractions by multiplying or dividing the numerator by the same non-zero number. In example 1, finding an equivalent fraction, we see the question, find 2 fractions equivalent to 4/12. So we're going to start A, 4/12 is equal to, times 3/3. This is where you multiply or divide the fraction by the same number. So we're going to multiply the top and the bottom, the numerator and the denominator, by 3. And what does that give us? 3 times 4 is 12. 3 times 12 is 36. So 12/36 is the same as 4/12 because we multiplied by 1 in essence, and that equals 1/3. B, 4/12, we're going to multiply by a different number to show you how you can use any number. It'll work. It could be a million, over a million if you chose. But 4 divided by 12 times 4 divided by 4 is equal to 16 divided by 48, because 4 times 12 is 48 and 4 times 4 is 16. Well, 16/48 is the same as 4/12 and is the same as 1/3. These are all equivalent fractions. The fractions 12/36 and 16/48 are both equivalent to 4/12, and they are equivalent to 1/3. So under example 1, check your understanding. We're going to do a little bit of the work ourselves. So it says find 2 fractions equivalent to each other. Well, we're going to start in A with 5/15. So what can we do to find an equivalent fraction to 5/15? So we can start with 5 divided by 15, and we can multiply this if you want by, let's do 3/3. So what does that equal to? 3 times 5 is 15, and 3 times 15 is 45. So what this is telling us is that 15/45 is the same as 5/15. Let's try again. Think about this one. 10 divided by 12 And we can multiply this by something. What do we want to multiply it by? Let's multiply it by 2. It could be any number. Like I said, we could use any number, but we might as well just keep them small so they're not too hard. So we're going to times 2 over 2. Because 2 over 2 is 1. You can multiply anything by 1 and not change it. So here we have 10/12 times 2 over 2 is equal to 2 times 10 is 20, and 2 times 12 is 24. So 20 24ths is identical to 10/12. It's an equivalent fraction. How about 14 20ths? 14 over 20 times, let's just do 2 again. 2 over 2 equals 28 over 40. 28 over 40 is identical to 14 over 20. Do we have that? Sounds good. So in Objective 2, we're going to be writing fractions in simplest form. A fraction is in simplest form when the numerator and denominator have no common factors other than 1. You can use the greatest common factor to write a fraction in simplest form. So if you remember from before how we do greatest common factors, well, you can use the little tree method, a factor tree, or a couple of different methods, but we'll find out as time goes on. Okay, let's do example 2, statistics. You survey your friends about their favorite sandwich and find out that 8 out of 12, or 8/12ths of the group, prefer peanut butter. Write this fraction in simplest form. So as you can see from the mathematics here, we've written 8/12ths. And the 8/12ths, how do we do that? We're dividing by this common number. We just learned that we could do that in the previous slide. We're dividing by the same common number, and we divide the 8 by 4 and we get a 2, and we divide the 12 by 4 and we get a 3. So now we see that an equivalent fraction in simplest form. This cannot be made any more simple than it is now. 8/12ths is equal to 2/3. And it shows here written differently. 8/12ths is 8 divided by 4 divided by 12 divided by 4, or 2/3. But how did we come up with the 4? The important question is, how did we get the 4? Wasn't it 3, or whatever the case? Well, as we also learned earlier, that you can look for the greatest common factor and use that as your divisor in both cases. So let's try it and see if that actually works or not. We'll see if that's part of the plan here. So we're going to start with the 8, and we're going to have a 12. So we're going to do the factor tree on both of them. So the 8, we can take a 2 out, and then we end up with a 4. And the 4, we can take a 2 out, and we end up with a 2 and a 2. So we have 3 2's associated with the 8. What do we have with the 12? Well, the 12, we can take a 2 out, which is good, and we end up with a 6. Now out of the 6, we can take another 2 out, and we end up with a 3. Oh, we're done. There's no more we can do. And what do we have in common? What are the common factors here, and what's the greatest common factor? Well, we don't have a 3 in both, so the 3 at this point is gone. We don't have to worry about the 3. With the 8, we have a 2 times 2 times 2, 3 2's. And the 12, we have the 2 times 2. So the greatest is 2 times 2, or 2 squared. This is 2 cubed. We can't use the larger number. We have to use the smaller, because there's a 2 squared in both. There's a 2 squared in 2 cubed. So the greatest common factor is 2 squared, and 2 squared is equal to 4. So there we can take the 8 and divide by 4, and the 12 and divide by 4, and we end up with this 2/3 over here. So now for example 2, under check your understanding, it looks like they want us to do a couple of our own here without the help. So let's start off by doing the 6/8, and let's find the simplest form for the fraction 6/8. So we're going to write the 6 over here, and I'll write the 8 over here, and I'll take a 2 out, and I'll take a 3 out. See, that's pretty simple. And as before, we'll take a 2 and a 4 and a 2 and a 2. So the highest common factor here is a single 2. There's only one 2 here. There's 3 2s here, and there's no commonality between 6 and 8 with 3. So the only common, the greatest, the GCF is equal to 2. So if we take 6/8, so 6/8, 6 divided by 2, divided by 8, divided by 2. And what does that give us? 6 divided by 2 is 3, and 8 divided by 2 is 4. So the answer of 6/8 is 3/4 in simplest form. Let's try the 9/12, the 9 and the 12. So 9 goes 3 and 3. So we have 2 3s over here, 3 squared. And 12 goes what? It goes 2 and a 6 and a 2 and a 3. The only common factor here is the single 3 that we have. This has 2 3s, this has 1. So the GCF is equal to 3. If we rewrite this, 9 divided by 3, all divided by 12 divided by 3, and that is equal to 9 divided by 3 is 3 over 12 divided by 3/4. Again, 3/4. 6/8 was 3/4. 9/12 was 3/4. Let's look at 28 35ths. So on this one, we're going to do a 28, and we'll bring the 35 over here. So 28 can do what? Can be take out a 2 because it's even, and we end up with a 14. 14 is even. We can take out another 2, and we end up with a 7. 7's a prime number. We've learned that. So we're as far as we can go here. On the 35, we can take out a 5. It's easy to take out because we see it ends in a 5. Might as well take out a 5. So take out a 5. And 9 times 5 is 8 times 7 times 5, right? We figure out which one it is when we're trying to factor this down. So it's going to be 7, because 5 times 7 is 35. After doing that little bit of mental math. So now we have, what's the common factors? We have a 7 over here, and we have a 7 over here. There's no 2's, and that's it. So our GCF is 7, is equal to 7. And if we take our equation and we say 28 divided by 7 all over 35 divided by 7, and we end up with what? 28 divided by 7 is 4, and 35 divided by 7 is 5. So the answer is 4/5. In example 3, simplifying a fraction, they want us to write in simplest form both A and B here, two different fractions. The difference here is all of a sudden there are variables in our fraction, these letters that are showing up, Y's and X's and A's and C's and B's, whatever. So these are all variables, but you can treat them as letters if you want to, and when you're putting them together, because you got to square them and cube them and that kind of stuff when you have multiples. But so let's start with the A, the first one. Y divided by X divided by Y. So they want us to find the simplest form, to reduce things that are unnecessary, so to speak, in here. So we see right off the bat that the numerator and the denominator both have a Y. So that is the same as saying Y divided by Y times 1 over X, because we separated the Y's from the X. Well, Y over Y is equal to 1, so that just disappears. 1 over X ends up being the answer because the Y's cancel themselves out. You look at those common multiple numbers that are being multiplied. You can't do that with addition, but you can do it with multiplication. Just cross them out. So now that's what we've done here. For b, it's 3ab squared divided by 12ac. Well, starting off, you can take, and what can you factor out of the numerator and the denominator? So we have a 3 all by itself, and on the 12 on the bottom, that's a 3 times 4. So as you see, they wrote 3 times, bring the variables in, a times b times b. And on the bottom, they turned that 12 into 3 times 4. So it was 3 times 4 times a, because they have a single a there, and b. The red, you see the red variables and numbers that I have marked off here. So then when you can factor those out, since they're in red here, we've made it easy to spot them. You can factor it out. So we can get rid of the 3's. They're going to cross out. The a's, the a on the top and the a on the bottom, it's gone. And there's a b on the top, 2 b's on the top and 1 b on the bottom in the denominator. And one set of those b's is gone, but it just leaves 1 b remaining. On the bottom is a 4. So the answer here is b divided by 4. That's in its simplest form. So here in example 3's check your understanding, they want us to write our own simplest form without any help, as the last slide had a little bit of help for us. So let's go ahead and try and see what we can come up with. So for a, we have b over a, b, c. These are all multiplied, so what we're doing now you can freely do. This b matches with this b, so this b can cross out and this b can cross out. And then the answer, since there's nothing on top, the answer ends up being a 1. They always have a 1. You can't, when you get rid of this b, it turns into a 1. And you have AC. So AC, 1 over AC is the answer to A. Let's try B. 2mn divided by 6m. Well, as we look at this, the m's can cross out. The 2 can cross out. And we can take a 2 out of the bottom down here, and it becomes a 3. So now that, and then the n remains by itself. So the top remains a single n, and the single n is divided by the 3 remaining here, and there's no m, so it's just 3. The m's are gone. Okay, the 2 was taken out of the 6, and there was no n, so it's n over 3. As for c, we have 24 x squared and y. And that's all over 8x and y. So as we look at that, we can say, well, there's only singular y's on the top and bottom, so we can cross them out, because the 1 divides the other and turns that into a 1. There's a single x on the bottom and 2 x's on top, so we can get rid of the x on the bottom and convert this one to a 1x. And then the 24 can be divided by 8, which is 3. So the 8 disappears and ends up being a 3 on the top. So the solution is 3x there's no y, divided by what? Nothing. Divided by 1, or simply 3x. Okay, now in our final slide, these exercises that we're going to do, there's 2 different questions. The first one says find 2 fractions equivalent to each fraction. So for A, we have 2 over 8, or 2 eighths. They want us to find a fraction, 2 fractions equivalent to A. Well, as we said, we can divide the numerator and the denominator by the same number and look at the result, or we can multiply the numerator and the denominator by the same number and resolve the results, get the results from that. So if we take the 2 eighths and divide the 2 by 2, and then divide the entire 8 divided by 2, what do we end up with? We end up with 2 divided by 2 is a 1, and 8 divided by 2 is a 4. So here's one fraction that's equivalent to 2 eighths. The other thing we could have done is we could have done 2 times 2 over 8 times 2, and that would have been 4 over 16. These two are equivalent. They're both a quarter. 4/16 is a quarter. There's a quarter. 2/8 is a quarter. These are equivalent. The next one, we have 3. Let's try divided by 3. 3 divided by 3 over 9 divided by 3, and that equals 1 over 3, because 9 divided by 3 is 3. So there's the one that I'm doing with a division. Let's pick one for multiplication. So it could have been 3 times 2 over 9 times 2, and that equals 6/18. Oops, 6/18. That's equivalent to 1/3, because 6 times 3 is 18. 1/3. Okay, now for the C, we have 5/15. Again, an equivalent one is we can take and divide the top by 5, and the bottom 15 divided by 5, and we come up with 1 over, 3. Again, a third, same as this one here. And to go the other direction, let's do times 3 this time. So 5 times 3 divided by 15 times 3, and that equals to 15 over what? 15 times 3 is 45. So these are all equivalent. 1/3, 1/3, 1/3, 1/3. These are 1/4 up here. For the next section, it says write each in simplest form. What's the simplest form of 3/9? Well, if we write this like this, if we went 3 divided by, put 9 into its factors, because you can't divide this further down. This is a prime. Is 3 times 3 is 9. Well, since these 3's cancel, we're left with 1 3 in the denominator. The answer is 1/3. So that's simplest form. For B, we have 4, which is 4/10, which is equal to 2 times 2 over 2 times 5. 2's cancel. You end up with 2/5. Hopefully that's clear. I think it's pretty clear. I like breaking them into their components. You could use the factor tree to come up with these, but these are very simple, so they're not too hard to factor them on your own in your head. 1/3. Well, 1/3, can 1/3 be any simpler than it already is? I mean, one's not a prime, but it can't be any further reduced. And 3 is a prime, so you are in 1/3 is the same. It is the simplest form. Okay. So now we're going to do the same thing a little further. We got writing in simplest form. We have three fractions that we're going to write in simplest form, but they're a little more complex because now they're variables and numbers. So let's start off by 2x over 3x. What can we factor out of this? I'll write it again. 2x over 3x. The only thing that we can certainly cancel out the x's, and that leaves us with 2/3. And 2 and 3 are both prime numbers, so that cannot be reduced any further. So simplest form, 4km squared over 12k. You can either do it in your head, because the k would cancel out here, and the 4 and the 12 makes you 3, and you have an m left. Or you can do this. You could say 2 times 2 times k times k times m, because the m squared, and then you can have all over, that line wasn't very straight, all over 4 times 3 times k. So here now you can see that the k's cancel out. I should have done the 4 as 2 times 2. So 2 times 2 times 3. So now these two 2's here cancel out these two 2's. So you've got the 3 on the bottom. and there's no m, and the m stays m squared. So the answer here is going, the 2's canceled, so it's 1/3, because the 3 remain down here. 1/3, the k's are gone. M squared is all that's left. 1/3 m squared. Going down to C. C, we have 40 a b squared over 5ab. So 5 you can't reduce any further. It's a prime number already. 5 goes into 40 how many times? 8. So the 5's gone now. Now we have the a's can cancel directly, so we can cancel that a with that single a, so they're gone. And then there's one b here, two b's here. This b cancels, and that becomes 1. So it's 8b is the answer for C. Write in simplest form. Some more to write in simplest form. So A, what is the simplest form of writing if you have 15 cubed divided by 15 squared? Well, there's 15 times 15 times 15, so over 15 times 15. So if we break it apart, you're going to say 15 times 15 times 15 all over 15 times 15. And those will cancel, those cancel, and all you're left with is a single 15 is equal to 15. Or you could subtract it, since you've done some exponents, so from a previous lesson, you should know that you can subtract these exponents here. But I like doing it since we're doing it, breaking it into factors. This is a good way to do it. So B is 5t divided by 10t squared. So what do we get? Well, the 5 cancels with the 10 because you get a 2. You divide the 5 into 10, you get a 2. So over here, we're going to have a 2 on the bottom, a 1 for the 5. But the t's, there's 2 t's here. This t is going to disappear, so it's going to cancel. This one's going to cancel, is going to cancel that squared t. So now we have 1 over 2t, because we were left with 1t when we got done here. Now finally C, 5c squared d all over 15c. Well, the d is going to remain because there's nothing to cancel it out. The 5 is going to go away because it's going to divide into the 15 3 times. So now we end up with a 3 on the bottom. So we have a 3 on the bottom. There's one c on the bottom, 2 c's on the top, so we're going to end up with a c on the top. And this will be gone, and this will be converted to a 1, and the d will remain because there's nothing to cancel it. So the answer here is CD divided by 3.